Researchers at a university in Thailand, Meijo University, have made something like a hot discovery. They found bacteria in hot springs that produce a compound that works as a natural sunscreen. Now, we've got hot springs here in our Rockies, of course, maybe not as tropical as the Thai ones, but could they be the key in protecting our skin naturally? Beth Richardson is here to help us answer that question. She's a biology professor at Mount Royal University. Can you walk us through the science here, break it down a little bit for us? What did these researchers find?
So these researchers were they were looking for what we call extremophiles, which is organisms that are biologically adapted to live in really difficult and kind of complex environments. And it's a really interesting way of finding new biology because obviously we don't live in hot springs. It's not something that is relevant to kind of us and our biology. So by looking at these organisms, we can understand things about how the natural world works that we wouldn't come across otherwise. And so in this paper where the authors looked into the microorganisms living in a hot spring in Thailand, so about 55 degrees, so just living 24/7 in a really hot bath, they found that there were certain compounds within those bacteria that were protecting them from UV light, which is a super common thing for plants to have. They obviously can't move out of the sun the way we can, and also they need to be in the light for photosynthesis. So there's a lot of really interesting compounds out there. So they have identified a new type of compound that had never been seen before. And from my perspective, as someone who works with environmental DNA, they identified the genes that are associated with producing that compound, which means that we might be able to identify similar genes in other organisms.
So can I then make the leap and say, if I take a dip in that hot spring in Thailand, I come out with a little bit of natural sunscreen on me?
Probably not.
Let's focus on the word leap there.
Yeah, you're probably going to get more sun protection from the mud you're going to stir up from the bottom of the hot spring by jumping into it than the molecule itself. But it's still really useful to know about these compounds because even though microbes only produce them in really small quantities because they've only got a really tiny surface area, if we can figure out a way of synthesizing that same molecule or getting a microbe to produce it naturally in larger quantities, then it is something that we could potentially use for pharmaceutical research.
Yeah, interesting. Well, and I love the idea that you make the point, like, they've found new biology. Like, it does expand the kind of world of what we know or what we're starting to understand. Now, hopefully this is less of a leap. Would this be similar to what we'd find in a hot spring in Banff?
Absolutely. So generally, anywhere you can find microbes, you do find microbes. They are incredibly good at adapting to different conditions. We find microbes in every environment in the world. We find them in clouds. We find them in the deep sea. And so there are definitely going to be microbes in hot springs in Alberta that will be adapted to very similar conditions. And one of the really interesting things about having that genetic information is that we often will have a whole bunch of DNA data that we have obtained, but we don't know what we're supposed to be looking for in it. So it's kind of like going into a library and knowing that there's loads of information out there that you could access, but not having any sort of index to be able to look up the book you want. Now that these Thai researchers have identified the specific genes that are associated with this pathway, that are associated with making this molecule, we can then say, okay, now we have a book name, we have a chapter title, and we can go exactly to look at what we want to find in the library. So not only does it provide us with new avenues for research, it also provides us with a way of reanalyzing data that has already been collected.
So are you heading out with a beaker or a test tube and going to scoop out of the hot spring?
Probably not today based on that traffic report, but you never know.
But it's coming.
Yeah.
Yeah. Oh, that's cool. So, yeah, I mean, what are the kind of research questions that this gets you out to, that this brings you to, and practical implications too?
So there's all sorts of different ways that you can kind of approach something like this. So if you are a chemist, you might look at it for, okay, can we synthesize this compound in a lab? If you work in pharmaceuticals, you might think, okay, how can we get this compound to be used for a product that people can use? As an ecologist, so my background is in microbial ecology, so I'm interested in how similar are these microbes that we find in the Banff hot springs to the Thai hot springs? Are we observing different microbes adapting to have similar processes and kind of evolving in parallel, or microbes they can travel pretty much infinitely on the air. So, if you want to move, for example, a bison from one area to another, it's got to walk there, but a microbe can just disperse. So we might even see similar organisms that have kind of made that jump from Thailand to Canada.
Now, I know you don't come at this from the sort of product development, pharmaceutical side, but the sunscreen question, how do you think this ties into our what we know and what we make and what we use in terms of sunscreen?
So there's been a lot of push. People really like using things like mineral sunscreens now. So the issue with sun exposure, it's from that UV ray exposure. And so sunscreens are designed to prevent UV rays from hitting your skin or to disperse them as heat. And so mineral sunscreens, they block the UV rays from hitting your skin. These type of sunscreen or these sunscreen molecules these cyanobacteria produce, they are dispersing this as heat. So because a lot of mineral sunscreens are based on things like titanium dioxide, zinc dioxide, there might be potential for this to be a slightly more environmentally friendly alternative to using something with a lot of metals in it, for example.
Yeah, interesting.